Hello, welcome to the nursing calculation YouTube video. So today we're going to learn unit conversions, dosage calculations, and IV flow rate calculations, and all without using any formulas. So before you can learn how to set up and solve these problems on your own without using formulas, you have to learn a few basic concepts. So what's more basic than a rock? So this rock weighs about 2 kilograms. So we can say it weighs 2 kilograms or 2,000 grams or 4.4 pounds. So whether we call it 2 kilograms or 4.4 pounds, it doesn't change. It's still the same rock and still the same weight. So the first basic concept you have to understand is nothing is changing. You're only going to be renaming the units. So nothing is changing. You're only renaming. So let's take a look at this rock and see how we actually do rename the units. So it was 2 kilograms, and let's say we want to rename it into grams. We're going to have to multiply it by something here. So let's talk about this ratio. So we know 1 kilogram equals 1,000 grams, right? We also know 5 equals 5. Now we can divide this 5 by this 5, that equals 1. Same thing over here. We can divide 1,000 grams by 1 kilogram, and that's going to equal 1. We can also say 1 kilogram divided by 1,000 grams is 1. Okay, so now we have these two ratios, and we can use those as tools to change back and forth between grams and kilograms. So in this case, we want to go from kilograms to grams. So we're going to have to cancel out kilograms and end up with grams. So we're going to have to be using this ratio, 1,000 grams over 1 kilogram. Those cancel. You're left with grams. So you have 2 times 1,000 grams equals 2,000 grams, right? Okay, so now let's take a look at this equation right here. We don't need the rest of the stuff, so get rid of that. So there's 3 parts to all of these problems. You're given something to work with. You're saying, here's 2 kilograms. Tell me how many grams there are. So you have a given, you have the units of the answer, and then you have a ratio. So the second basic concept is all the problems have the same 3 parts. You have a given, units of the answer, and 1 or more ratios. So what does that all boil down to? It boils down to the given times the ratio equals the answer. And this is pretty much the whole course right here. If you can understand that, you can do pretty much any of these problems. Okay. So let's go ahead and do some unit conversions. Okay. First one, how many milligrams in 3.5 grams? Okay, so they're giving you 3.5 grams and asking you how many milligrams. So you got 3.5 grams equals milligram. Okay, we know that there's 1,000 milligrams per gram. Right? So they cancel out. You have 3.5 times 1,000 milligrams equals 3,500 milligrams. Okay, pretty simple. Convert 185 pounds to kilograms. The given is 185 pounds. And you know you have 2.2 pounds per kilogram, right? And kilograms will have to go on top. Whoops. That's the beauty about this system. If you goof up, you know right away, right? Okay, so 185 divided by 2.2 is about 84.1. Right. Okay. Convert 2.7 liters to mLs. So the given is 2.7 liters, and you want ml. So there's 1,000 ml per liter, gives you 2,700 ml. Okay, pretty simple. Okay, let's think we're on dosage calculations, right? Okay. So now, the given on the dosage calculations, that's going to be what's prescribed, okay? So the order is 175 milligrams, and on hand you have 25 milligram per ml. How many ml do you administer? Okay, so we got 175 milligram, and we want to end up with ml. Okay. So the ratio of milligram to ml is 25 milligram per ml. We'll need ml on top because we have to end up with that, and milligram on the bottom. So we've got 1 ml over 25 milligram, right? They're gone. So 175 divided by 25 is 7 ml. Okay, since we're on dosage calculations, I know that a lot of you like that D over H times Q. Equals X. So that's the desired over the have or on hand times quantity. So what that works out to, the desired is the 175. Then the have, the way they say have is just the milligram part. It seems to me it should be 25 milligram per ml is what you actually have, but we'll just do it this way. So 25 milligram, and then the quantity is 1 ml. So that's going to give you your 7 ml. So what all they've done here is they've taken this part here, which is the ratio of milliliters to milligrams, and split it up, put half of it under your given, and then the other half off to the side there. It's basically doing dimensional analysis, but just splitting up the ratio. And I really think once you learn, the dimensional analysis method, you'll see that that other formula is just kind of breaking things up, and you should be able to just go directly, just multiply just by the ratio multiply the given by the ratio and get your answer. Okay, number 2, order 0.25 milligram on hand is 125 microgram tablet. How many tabs do you administer? So the given is 0.25 milligram, and you want to end up with tabs. So the ratio of micrograms to tablets is 125 microgram per tablet. You need tablet on top. So, milligram and microgram don't cancel, but that's not a problem because all you have to do is throw in another ratio of milligrams to micrograms so that they cancel out. And of course there's 1,000 microgram per milligram. So now these all cancel out and you're left with tab. So the math or the arithmetic is 0.25 times 1,000 and you have the units of tab divided by 125. So 0.25 times 1,000 is 250, of course, and then divide by 125. So it's going to give you 2 tabs. Okay. So the beauty of doing it this way is that if the units don't match up, it's not a problem. You just add in another ratio. If you use the D over H times Q, you're going to have to convert to the same units. Either with you have to change the order or the tablet so they match up. Okay. Let's see what's next here. So you have order is 500 milligram, and you have 100 milligram per 2 ml. How many ml? So they're given 500 milligram, and you want ml, and so you have to have ml on top, milligram on the bottom. So in this one, you're going to have 500 times 2, so that's 1,000 divided by 100, and then the units are ml, so that's going to work out to 10 ml, right? Okay. When you do these problems, the most important part are the units. You have to always put the units on there so you know you can keep track of what you're doing. The numbers just kind of go along for the ride, and then at the end you take care of them. Okay. Okay, so now we're going to talk about some IV flow rate problems. Okay, so these are just a little bit more involved, but they're still pretty easy. So there's three main types of IV flow rate problems. The most common is a rate to a rate. So they might say the doctor ordered 100 mLs per hour, and you want drops per minute. Okay, so that's a rate to a rate. The other type is a time to a quantity. They might say a bag has been running for 2 hours at a certain rate, and how many liters have been infused. So you have a time to a quantity. And then the last type is a quantity to a time. So they might say 2 liters have been infused at a certain rate, and then how many hours is that? So you have a quantity to a time, right? The key on these problems is to look at the units of the answer first. If it's a rate, then you know you have to start with a rate. If it's a quantity, you know you have to start with a time. And if it's time, you have to start with a quantity. Okay. So let's see what we have here. So a 1 liter bag infuses over 5 hours. What's the rate in mLs per hour? Okay, so the units of the answer are mLs per hour. That's a rate. So you have to start with a rate, and the only other rate in the problem is 1 liter over 5 hours. So now you can see you have to change liters to mLs. You don't have to do anything with hours, right? So there's 1,000 mLs per liter. They cancel. And now all you have to do is divide 1,000 mLs by 5. Okay, and that will give you 200 mLs per hour. You got mLs per hour. It's pretty easy. Okay, what's next? So you have 100 mLs is infused over 1 hour using an infusion set with a drop factor of 10. So that means 10 drops per ml. What is the rate in drops per minute? Okay, so the answer is in drops per minute. So that's a rate, of course. So you have to start with a rate, which is 100 mLs over 1 hour. Put a 1 on there. And so now we can see that we have to change hours to minutes, mLs to drops. So the 10 drops per ml, that's going to change mLs to drops. We just have to put drops on top. They're gone. Now, hours to minutes, we all know, of course, 60 minutes per hour. So we need that 1 hour on top, 60 minutes on the bottom. Hours cancel. Now we have drops per minute, drops per minute. Now we can do the calculations. So you have 100 times 10 divided by 60. And then you have your units of drops per minute. So that's going to be 1,000 divided by 60. So rounded up to 16.66 or 16.67. So you can round that to 17 drops per minute. Okay. Let's see. Okay. Number 3, a 1,000 ml bag has been running at the rate of 50 mLs per hour for 4 hours. How many mLs have been infused? Okay, so the units of the answer are ml. That's a quantity. So it has to start with a time, right? So the time is 4 hours. So it's just 4 hours, and you want to end up with mLs. Right. Okay, now the ratios, you have 50 mLs per hour. Okay, so 4 times 50 is 200 mLs. Okay, that was an easy one, right? Let's see. Okay, so how long will it take to infuse a 1 liter bag at the rate of 125 mLs per hour? Okay, so the units of the answer, it just says how long. It doesn't say how many hours, but you can just figure it's going to be hours because it's going to be probably more than just a few minutes. If it is just a fraction of an hour, you can always change it to minutes. But let's just, for now, assume it's going to be hours. And so since you're ending with a time, it has to be a quantity. So you're going to be using the 1 liter. And then the rate is 125 mLs per hour. You need hour on top and mLs on the bottom. Of course, those don't cancel, but no problem. That cancels, mL's cancel. Now you're left with hour. So you have 1,000 divided by 125, and that's 8 hours, right? Yeah. Okay, so that's all the IV flow rate questions. Okay, so the takeaway from the lesson today is that there's 3 different types of problems, but they're all actually done the same way, right? You have your given, you got a rock or whatever, a dosage or something to convert. You have your tool, which is your ratio. You take your tool to your given and you get your answer, okay? So thanks for watching, and if you liked it, I hope you give me a like on the YouTube thing there. Okay, thanks.